What makes a giant, well, a giant? You know, big, enormous, you get it. Tough questions. It depends on who you ask. The ancient Greeks had cyclops, while ogres were spread out through all sorts of European folklore tales. The tallest person ever recorded was named Robert Pershing Wadlow, and he lived in the first half of the 20th century. He stood at an incredible 8 feet 11 inches tall, but had many medical issues throughout his life. Sadly, he only lived to celebrate his 22nd birthday. That's because Robert wasn't just tall. He had a condition affecting his human growth hormone, which didn't particularly make his life comfortable. Robert even had to wear leg braces in his adult years. During that same time, incredible discoveries were reported in North America. Some people claim to have uncovered weird-looking skeletons, much larger than previously associated with human beings. It immediately raised the question, did giants really used to roam our planet? Our story begins with the idea of a mound builder race. Some scientists back in the day claimed that these massive earthworks in places like the Mississippi Valley, called the Grave Creek Mound or the Great Serpent Mound, were built by some sort of prehistoric type of human, much larger and stronger than us Homo sapiens are today. From around 1812 to the 1860s, almost everyone in America writing about history was covering this mound-building race. However, not everyone agreed with the theory. There was this naturalist named Benjamin Smith Barton, for example, who warned about jumping to conclusions about giants. He believed that just because people discovered some big bones, they shouldn't immediately think of giants. But people didn't listen. Really? They simply wanted to believe about huge human-like creatures, despite not having any real scientific evidence. Newspapers were filled with these giant stories. They described finding giant skeletons, even featuring weird body parts. Con artists took advantage of the whole frenzy, with some putting together skeletons out of wood and rawhide and touring them as proof of the long-lost race of giants. Eventually, in the 1930s, an anthropologist from the Smithsonian took it upon himself to debunk the whole mystery. And his conclusions were straightforward. All those giant skeletons that were supposedly uncovered were either hoaxes or simply animal bones that were wrongly identified as belonging to humans. He also said that those who claimed to have discovered ancient giant remains were just not that good with human anatomy. You would think that's how the story ended. Well, it didn't. You see, people became so convinced that giants existed that they simply could not let go. Sound familiar? Because the Smithsonian was investigating these claims, some people started thinking they were up to something shady. They cooked up this theory that the Smithsonian scientists were secretly getting rid of giant bones to hide the truth about giants. This whole story survived through the years and made it all the way to 2014. Is when this internet article said that the Smithsonian used to have tons of giant skeletons but destroyed them back in the early 1900s. And the drama continued. A famed publication even looked into the past of some of those Smithsonian scholars to try and pick apart their credibility. So the Institute had to do some damage control. They've since added new people on the team whose job is to figure out if those bones were correctly collected and studied. Now, it wasn't just North Americans that claimed to have stumbled upon giants. The French had their own discoveries too. Their story takes us back to 1890, when an anthropologist was digging around a Bronze Age site in Castelnau, France. What he found were 3 bone pieces that looked like they came from a giant human. The findings included a massive thigh bone, a shin bone, and a regular upper arm bone known as a humerus. Now, if we put all these bones together and calculate the proportions, they lead us to this towering figure, somewhere between 10 and 11 feet tall. However, in 2022, contemporary scientists took another look at those bones. They concluded they most likely belonged to a cave bear, not a human. It wasn't that unusual for people back in the day to confuse giant animal bones with those of humans. Now, the truth is, our ancestors were in fact taller than we are today, despite them not being technically giants. The average human body has changed a lot over thousands of years. we're not as big and strong as our ancestors were. In fact, we've been on a bit of a downsizing trend, especially in the last 10,000 years, and it's because of a mix of factors. Our genes, the world around us, and how we live our lives all play a role. Way back around 40,000 years ago, European men were towering at around 6 feet. They had a seriously tough life, though, hunting and gathering all day. That lifestyle required a good muscle structure, and their African roots might have given them that extra height, which came in handy in warm climates. Moving on to 10,000 years ago, we can already see a big change in European males. They went down to 5 feet 4 inches on average. What happened was the climate was shifting, and people were increasingly relying on agriculture to provide for their families. It wasn't all sunshine and comfort, though. Sometimes failed crops and a not-so-diverse food meant a pretty unhealthy diet. Plus, being around farm animals more and more introduced some new medical issues to the mix. We're now around 600 years ago when the shortness continued, and yes, we can still blame it on poor diet and health. However, there seems to be a change in recent years. Today, European males are reaching an average of 5 feet 9 inches. And sure, the fact that we're eating more veggies and getting regular checkups at the doctor did help a lot. But it's also because of industrialization and living in cities. This has brought people from different backgrounds together, which is a good thing. It decreases the chances of human passing on genes that could cause problems. So, it's a combination of better living and genetics that's making us taller. We shouldn't give up on ancient giants quite yet, though. You see, experts believe they recently discovered the remains of such a person who supposedly lived in ancient Egypt. Sometimes people can actually grow to large sizes due to a condition called gigantism, the same that made Robert Pershing Wadlow grow to such an impressive height. When some archaeologists were studying ancient Egyptian mummies, they came upon an interesting skeleton. What made it special was that they believed it might have belonged to a pharaoh, who would have been really tall, like 6 feet 6 inches tall. To put that in perspective, that's way taller than Ramses II, who was the tallest recorded Egyptian pharaoh and stood at about 5 feet 9 inches. These experts took a closer look at the newly found bones, especially the long ones, and found evidence of something called exuberant growth, which basically means this person's growth was off the charts. It's a clear sign of gigantism, they say. Now, this discovery is important because it makes this mummy the oldest case of gigantism in the world. No other Egyptian pharaohs were known to be giants. It's also fascinating because it tells us something about the health and nutrition of ancient Egyptian rulers. See, those pharaohs were probably better fed and healthier than regular people, which might explain why they could grow taller than the average person. Now, you might be wondering if being a giant had any drawbacks back then. Well, it's hard to say. I wasn't around then. Still, during those early dynasties in Egypt, they seemed to prefer shorter people, especially in royal service. There are a lot of ancient Egyptian stories featuring short-statured leaders and even higher spirits that locals looked up to. The reason why is still a mystery that we might never fully solve. But since this mummy was found in an elite tomb, it's possible that being a giant didn't have a social stigma attached to it at the time. Maybe he was, in fact, seen as special.
The profession of a travel blogger is far more ancient than you can imagine. Yeah, the first ones appeared around 2,500 years ago. Meet Herodotus, historian, travel blogger, genius, billionaire, philanthropist. Just kidding. Herodotus had been all over the place, and by the time he hit 60, he had seen more spots than anyone else on Earth. As Instagram wasn't around yet, he had to whip out his papyrus and wrote what we now know as the first ever travel guide, the Histories. In his book, he spilled the tea on people, places, animals, and plants. He was particularly fond of Egypt. By the way, most of the stuff Herodotus described is still there, so his guide is not that outdated even today. If you're ever in Egypt, you can actually check out the same monuments and sites Herodotus saw. One spot that Herodotus cruised to was Lake Moeris down the Nile. This place was legit. a freshwater lake that got its water straight from the Nile. There was this city called Crocodipolis chillin' on its shores. Yep, there were a lot of crocodiles there. That city is also still around today, just under a different name, Fayum. Right in the middle of Lake Moeris, there were two giant pyramids that took Herodotus' breath away. Here comes the mystery. At the moment, these two pyramids are gone. Seems like, according to the travel guide, we're missing two Egyptian pyramids. Herodotus claimed Lake Moeris was man-made, like someone dug it up with their bare hands. He thought so because there were two pyramids smack dab in the middle of the lake. But let's face it, it would have been physically impossible to build something like that in a natural lake. I mean, the ancient Egyptians were pretty advanced, but they definitely didn't have scuba divers and all the essential equipment back then. The pyramids were 50 fathoms above the surface and another 50 fathoms below. Just to give you an idea, 1 fathom equals 6 feet, so those pyramids were around 600 feet tall. That's taller than the famous Pyramid of Giza. And while the Pyramid of Giza has a modest little capstone, these twin pyramids had statues of pharaohs chilling on top. That's why you've never heard of them, and there are only a couple of drawings depicting them. So what happened? Well, time is ruthless. Take the Great Labyrinth Herodotus mentioned, for example. Nowadays, it's just a pile of rubble and cobwebs. Even the once magnificent Lake Moeris has changed. The water there has turned salty, and now it's just a fraction of its original size. Sure, change is inevitable, but you would think pyramids would stand strong against the test of time, right? Their unique designs make them super durable. So where are these pyramids now? Well, chances are they never actually existed. We all know that some travel bloggers tend to exaggerate, right? Herodotus was no exception. While some people call him the father of history, others call him the father of lies. Ouch! Yeah, his books have false or unverified information sometimes. For example, he totally blew up the size of the Pyramid of Giza in his guidebook. He doubled its size. But hey, cut the guy some slack. In the pre-Google era when our travel blogger lived, fact-checking was pretty complicated, especially for Herodotus, who couldn't even read those funky Egyptian hieroglyphics. He had to rely on the locals for info. Those inconsistencies in Herodotus' book might be just one epic prank pulled by mischievous locals on a clueless tourist. Classic. However, there are actually some legit monuments at the site. The pedestals of Byamu are the leftover bases of two ginormous statues built by the ancient Egyptian pharaoh Amenemhat III. These ruins used to grace the shores of Lake Moeris, but now they chill in the Fayum Oasis, about 4 miles north of Fayum City. The first time these statues were mentioned was by, you guessed it right, the Greek historian Herodotus, who was around in the 5th century BCE. Remember the description? Herodotus said there were two pyramids that soared 50 fathoms above the water surface, and each pyramid had a massive statue sitting on the throne at the top. We have the statues, but not the pyramids. Weird, right? There's an explanation though. Some scientists believe that Herodotus probably wrote about these statues during a time when the area was flooded. But hey, it's not just Herodotus who spun this tale. Diodorus the Sicilian and Pliny the Elder also jumped on the bandwagon, repeating similar claims about these colossal statues. However, let's not forget that Herodotus might have been a bit lazy. He never actually got up close and personal with the statues. He just saw them from across the lake. So picture this. Hazy silhouettes in the distance, and Herodotus' imagination running wild with their grandeur. The description matches, except for the height. While Lake Moeris pyramids seem to be a myth debunked, there's another mystery waiting to be unveiled. Some time ago, archaeology researcher Angela Mickle dropped a crazy discovery. She claimed to have found not one, but two lost pyramid sites in Egypt. The craziest part is that she didn't even have to leave her couch to find them. She basically found those pyramids online. After spending 10 years studying Google Earth, Angela managed to pinpoint these two areas along the Nile Basin. They're about 90 miles apart, and both have some funky-shaped mounds. The first one is chilling by the Nile in Upper Egypt, just 12 miles away from Abu Sidum. The second one, 90 miles north, has a 140 feet wide four-sided shape. The second site even has a massive triangular plateau that's a staggering 620 feet wide. Angela wrote on Google Earth Anomalies back in 2012, saying that the mound looked super flat on top and had a crazy symmetrical triangular shape that had been worn away over time. And the second site? It got this square center that's totally out of the ordinary for a mound this size. It almost looks like a pyramid when you see it from above. But not everyone is convinced. Some Egyptologists say these mounds are just geological features called buttes. Apparently, they're pretty common in the local Fayum Desert. These buttes form when sediment piles up and there's a stubborn layer that doesn't want to erode. So when the surrounding sediment washes away, that tough layer stays put and makes the hill all flat. Still, this one's just a theory as of now. By the way, Egyptian archaeologists just made one more incredible discovery. This time, it's not a theory, but an actual site. In January 2023, they found a complete residential city from the Roman era right in the heart of Luxor, a southern city in Egypt. This ancient city, dating back 1,800 years to the 2nd and 3rd centuries, is actually the oldest and most important city ever found on the eastern bank of Luxor. The archaeologists uncovered a bunch of awesome stuff during their excavations. They found several residential buildings, 2 pigeon towers that were used to house pigeons or doves, and even some metal workshops. Inside those workshops, they stumbled upon a treasure trove of pots, tools, and Roman coins made of bronze and copper. It's like a real-life time capsule. This kind of find is pretty rare in Egypt. Usually, they come across temples and tombs during excavations, especially on Luxor's west bank, where the famous Valley of the Queens and Valley of the Kings are located. But this time, it's all about this amazing residential city. And get this, back in April 2021, they announced the discovery of a lost golden city on Luxor's west bank that's 3,000 years old. The archaeological team called it the largest ancient city ever found in Egypt. It's like they're uncovering hidden treasures left and right.
Hold on to your hats, folks, because we're about to embark on an incredible journey. With the help of super smart scientists and their studies, we've asked AI to take us back a mind-blowing 2 billion years in time and show us what our awesome Earth looked like. So buckle up and let's find out. Once upon a time, way back when Earth was just a baby, around 4.5 billion years ago, hopping into a time machine and paying a visit would have been a big mistake. The whole place was a hot mess. First of all, the ground was still all gooey and molten, so landing your time machine would have been a major risk. Now, as soon as you tried to get out, you would see a completely different Earth compared to what we know today. The landscape is a patchwork of rugged mountains, sparkling seas, and vast stretches of land. Picture massive volcanoes erupting in fiery bursts, shooting gases and ash into the air. It's like a crazy fireworks show. And even if you had a fancy new machine that could hover and had special shields to handle the heat, you'd still have a hard time breathing. You see, the early Earth's atmosphere is a bit moody. Thick clouds hang in the sky, casting mysterious shadows on the land below. The air is as thin as a whisper and filled with all sorts of interesting gases like hydrogen and helium. Carbon dioxide swirls around, giving everything a vibrant green hue. Water vapor drifts through the air, creating a sense of humidity and a refreshing mist. Oh, and there might be a hint of ammonia and methane just to keep things interesting. Lots of cool gases, huh? But wait, there's something missing. Oxygen. So if you take a deep breath, you won't feel that familiar rush of air filling your lungs. On land, there are no lush forests or towering trees just yet. Instead, you find rugged, rocky terrains. Some of these ancient rocks bear the marks of intense forces, collisions and earthquakes that have shaped the land over millions of years. But amidst all this ancient beauty, something amazing is about to happen. Life, in its early stages, is evolving and preparing for its grand entrance. Simple organisms, like algae and bacteria, rule the scene. They thrive in the oceans, using the abundant carbon dioxide to grow and multiply. The waters are teeming with activity, with colorful, microscopic life forms buzzing around like a busy city. These tiny organisms are working hard, releasing oxygen as they go about their business. They're like little factories, slowly changing the composition of the atmosphere. So this is what the early Earth looked like, more or less. But why was it so nasty? And how could it have changed so much since then? You see, Earth's heat came from all sorts of crazy things happening during its formation. First off, there was some serious heat already packed into the objects that came together to make our planet. Then, as Earth grew bigger and stronger, its gravitational force got a major power boost. It pulled in more stuff, but it also gave Earth a massive bear hug, squeezing everything tightly. And you know what happens when things get squeezed? They heat up like a pressure cooker. This crazy heating had a huge impact on Earth's structure. Picture Earth as a mixed-up bag of rocks, metals, and minerals. But as things heated up, the rocks and metals got so toasty that they melted. And guess what? The denser metals sank to the center and became Earth's core, while the lighter rocky stuff floated up to become the crust and mantle. It was like Earth decided to unmix itself, creating separate layers. Scientists call this wild separation differentiation. But the heating didn't stop there. With all this mixing and moving around, Earth got even hotter. It was like turning up the heat in a giant planetary oven. All this crazy heat had some serious consequences. Earth's high temperature made everything super speedy. Tectonic plates were dancing like there was no tomorrow, making the surface super active and full of geological shenanigans. Oh, and that's not all. Earth also got showered by some serious cosmic visitors. Imagine this. While Earth was busy gathering up all sorts of space debris during its formation, the rest of the solar system was causing some major chaos. Saturn and Jupiter decided to shake things up by changing their orbits, sending a whole bunch of massive objects hurtling towards poor Earth. These collisions were no joke. They packed a punch that melted minerals in Earth's crust and even vaporized them. These booms were so intense that they even blew gases right out of Earth's atmosphere. Talk about a wild fireworks show. Believe it or not, we can still spot ancient battle scars from these collisions. It takes some careful detective work, but we can catch a glimpse of their aftermath. For example, there's this place called the Manitsok Crater in Greenland. Even though there's no actual crater to see, we can examine rocks that were chilling 12.5 to 15.5 miles below Earth's surface back in the day. And guess what? They bear the marks of intense and sudden shock. Now that's some tough neighborhood. The wildest collision of them all was with a planet called Theia. Theia, about the size of Mars, crashed into Earth with a mighty bam! It was a colossal event that changed everything. Theia's metal core fused with Earth's core, while the outer layers of both planets got shattered and tossed into space. The result? A beautiful ring of debris encircling Earth. Now here's the coolest part. That debris didn't just float around forever. It started to come together, like puzzle pieces finding their match. And voila, we got our very own moon. Can you believe it? And this incredible moon-making process might have taken as little as 10 years or even less. Crazy, isn't it? Scientists call this whole moon-forming extravaganza the giant impact hypothesis. So next time you gaze at the moon in the night sky, remember that it's actually a huge chunk of our own planet. And by the way, Earth also had quite the adventure trying to create its atmosphere. In the beginning, our planet's first attempt at an atmosphere didn't go so well. It had a thin layer of hydrogen and helium that came along with all the stuff it gathered. But those gases were like sneaky escape artists and decided to float away into space. Bye-bye, gases. Luckily, Earth didn't give up. It went for a second round, and this time it was much more successful. Volcanic eruptions came to the rescue. They spewed out all kinds of gases like water vapor, carbon dioxide, and a whole bunch of other funky ones. Even meteorites and comets joined the party, bringing lots of water and nitrogen to the mix. Earth's atmosphere was becoming quite the party. But here's the funny thing. There was no oxygen to be found during the second experiment. Nope. Not a single breath of it. The oxygen that was produced by the sun's rays splitting water molecules got gobbled up by chemical reactions faster than you can say, oxy-bummer. It wasn't until Earth's third experiment came along, life, that things started to change. Photosynthetic organisms took center stage and used all that carbon dioxide in the air to make their food. And guess what? They released oxygen as a sidekick. Eventually, the organisms started belting out so much oxygen that it overwhelmed the reactions, and it began to fill up the atmosphere. It took a while, though, and it wasn't until about 350 million years ago that we got the oxygen levels we have today. About 21% of the air we breathe. So, from fiery volcanoes to mysterious oceans, this glimpse into the past reveals an Earth vastly different from the one we know today. It's fascinating to explore the ancient landscapes and imagine the early stages of life taking shape. Thanks to AI, we can catch a glimpse of Earth's remarkable history and appreciate the wonders of our ever-changing planet. So, stay tuned for more interesting journeys.
One iced frappuccino for me, please, and with a double shot. Now, I suspect this is something you'd never hear if you traveled 100,000 years ago to check out on your super great-great-great-grandparents. First off, you wouldn't hear anything resembling human speech for a simple reason. The early humans developed a capacity for language about 50,000 years ago. So, to talk to your ancestors, you'd need to use some of the oldest forms of human communication, including talking or making sounds, drawing or painting, dancing, acting, and using symbols. For example, if you made some weird noises like grunts or guttural sounds, it would mean you're trying to communicate with your peeps or warn them about something. Another reason why no one would grab iced frappuccino back then is that 100,000 years ago, Earth was going through a serious ice age. Who wants an icy, refreshing drink in the middle of winter? It wasn't quite a full-blown glacial period, but it was definitely way colder than it is now. The sea levels were low and there were glaciers everywhere, which made it super tough for our early human ancestors to get around. Some even kicked the bucket while trying to migrate to other areas, especially up in Northern America and Europe. Back in the day, when humans were still figuring out this whole survival thing, they chowed down on some pretty, fancy stuff. We're talking tartar steak, sashimi, you name it. Okay, I'm exaggerating a bit. It wasn't an iconic fresh dish, but raw meat. Not a Japanese cuisine staple, but a plain fish. There weren't Michelin restaurants serving fancy dishes and Gordon Ramsay recipes, but prehistoric foodies happily munched on nuts, seeds, and berries. And you know what? Their lifestyle is gaining popularity today. And there's even a so-called paleo diet. Paleo stands for the Paleolithic period. The idea is all about eating like our early human ancestors did. Some scientists believe that our genes haven't quite caught up to the modern diet that came from farming. Thanks to farming, we've got grains, legumes, and dairy galore. But it turns out that these changes in our diet happen faster than our bodies could keep up with it. 100,000 years ago, humans roaming around were basically just like us in terms of looks and DNA, but their houses were far from being modern. Actually, those were just caves. They couldn't even buy a mere bed in IKEA. Scientists in South Africa just discovered what they're calling the world's oldest bed. And no, it's not a fancy mattress with adjustable firmness settings. It's actually made of grass. Archaeologists stumbled upon mats of grass and sedge that were stacked half an inch thick on the floor of a rock shelter. And get this, the bedding is 77,000 years old. That's like 40,000 years older than the previous record holder. The mats were covered with leaves from a tree called the river wild quince, which repels pesky insects. These prehistoric folks were basically having a bed and breakfast situation going on in their cave. But let's be real, living in a cave is pretty gross. Insects, rot, and lice are just a few of the issues. But instead of bouncing to a new spot when things got nasty, these people burned their bedding and made new ones. Yeah, seems like 100,000 years ago, life on Earth was totally wild. Sure, microbes and amphibians were chillin' for billions of years before that, but things were way different back then. So, during a prehistoric trip, you could have bumped into one of the biggest mammoths ever. Yup, the Columbian mammoth was a beast. Standing at 13 feet tall and weighing over 10 tons, It had curved tusks that were even longer than its body, somewhere over 16 feet. These weren't like those woolly mammoths you see in movies with their thick brown fur. The Columbian mammoths didn't need that kind of coat, because they didn't live in the icy regions of Europe and North America. But don't let their lack of fur trick you. These creatures were massive, and could have been a real threat to humans who lived near them, even though they were plant eaters. Another beast you'd stay away from is Toxodon. This land animal had some seriously cool curved teeth that gave it its name. It looked like a rhino, but with some similarities to rodents too. The last one was spotted only 5,000 years ago, and that's pretty recent in the grand scheme of things. Charles Darwin even used the Toxodon as an example to explain evolution and anatomical differences. Some people think it might have been semi-aquatic, but its grass-eating habits suggest otherwise. Not only was the Earth full of cool animals, but it also had a diverse human population. There were all sorts of new species popping up left and right, and they were on the move, looking for a better place to call home than Africa's dry and dusty areas. One of those species was Homo floresiensis, aka the hobbits. These little guys were only about 3 feet tall and hunted for their food using stone tools. They were totally unknown until recently, when scientists found their remains in caves all over the world. Homo erectus were the first humans who actually looked like us. They were total trendsetters, standing upright and all. They were the first to explore outside of Africa and check out other continents. These guys were pretty smart too, making cool tools and even cooking their own food. But unfortunately, they got a little too comfortable and lazy. They didn't keep up with the changing climate and eventually went extinct. It's a shame, really, because while other humans were hustling to improve their tools and survive, Homo erectus just couldn't keep up with the times. Lesson learned: don't be afraid to get out of your comfort zone. Homo sapien Neanderthals were basically our ancient cousins who lived in Europe and Asia. They were pretty smart and used fancy stone tools to hunt and survive. But let's not get too carried away with their intelligence, okay? The media likes to hype them up as geniuses, but there's not a ton of evidence to back that up. Modern people are the only non-extinct human species. You and I are part of the Homo sapiens sapiens subgroup that roamed the Earth 100,000 years ago, too. We were so smart that we even migrated out of Africa to Europe and Asia. Our intelligence was apparent from the very beginning. By the way, the era we're traveling in was called the Stone Age, as back then people learned how to tame stones. That was a tremendously large era that started over 2 million years ago, and it only finished in 3300 BCE. Let's dive into Plombos Cave. It's a super cool spot located in the Plombos Private Nature Reserve on the southern Cape Coast of South Africa. The cave may be small, only around 430 square feet, but it's got a big history. Early modern humans were all about Plombos Cave, visiting repeatedly between 100,000 to 70,000 years ago before a sand dune partially sealed the entrance. Above the sand dune, you'll find material from the later Stone Age. The coolest discovery? 2 pieces of ochre with geometric engravings that were found in 2002, marking one of the earliest signs of symbolic communication among early modern humans. It's about 75,000 years old. And it doesn't stop there. More engraved ochre pieces have been found in later excavations, proving that this type of communication has been around for ages. Plus, they found red lines of ochre drawn on a rock that dates back to 73,000 years ago, showing that painting was also happening back then. Also, in 2008, they discovered a 100,000-year-old ochre processing workshop with a couple of toolkits at Plombos Cave. These toolkits consisted of 2 abalone shells containing an ochre mixture that was possibly used for painting or other purposes. Our technology has sure made a quantum jump since the first tool ever was invented. But just so you know, it all started with pointed stones in Plumbo's cave. Yeah, probably the reason why you have the internet today is because some prehistoric dude in Plumbo's cave learned how to use pressure flaking and managed to sharpen the very first stone ever. And there were some inventions in between that, but yeah.
In a frosty Canadian park, hidden deep beneath layers of thick ice, scientists discovered a bizarre skeleton they named the Frozen Dragon. The skeleton had been in the frozen ice for millions of years. It took experts decades to work out the species of this strange fossil. It was identified as a new genus of pterosaur. Pterosaurs were massive flying reptiles with wingspans of over 16 feet. Their heads were 3.5 times the size of their bodies. Pterosaurs lived 76 million years ago, when they soared above the dinosaurs. Scientists described them as the biggest, meanest, and most bizarre animals that ever flew. The new genus has been named Cryodragon boreas, which translates to Frozen Dragon of the North Winds. In 2013, a young mountaineer was climbing one of the tallest mountains in Western Europe, Mont Blanc. He noticed a strange metal box poking out of the snow. The mountaineer pried the box open and found that it was filled with precious rubies, emeralds, and sapphires. The climber immediately handed the box to the authorities. It was discovered that the box likely belonged to a passenger on one of 2 flights from India that crashed into the mountain over 50 years ago. The box was valued to be worth over $200,000, and authorities are still searching for the heir to the small box of treasures. In northwest Siberia in 2007, a reindeer herder was on an outing with his sons when he noticed something strange in the ice. The man realized it was a frozen mammoth calf and immediately contacted the local museum. The calf was named Luba and was the best preserved mammoth mummy in the world at the time of its discovery. Luba had been in the ice for 41,800 years and is around 30 to 35 days old. From trunk to tail, the mammoth calf is roughly the same size as a large calf. If you're interested in seeing for yourself, Luba travels to museums all around the world. On the frozen continent of Antarctica, covered in layers of ice and snow, is Mount Erebus, the frozen volcano. The volcano was discovered in the middle of an eruption in 1841 by explorers on an Arctic expedition. The volcano is over 12,000 feet tall and has been active for the last 1.3 million years. Deep within the middle of the volcano is a huge crater filled with large volumes of molten lava. The volcano has occasional explosions, which means it's classified as being in continuing eruption. However, these eruptions are nothing to worry about because they're generally rather small. Back in 1991, 2 hikers were traveling across the Italian Alps when they stumbled across a body that they presumed to belong to a recently lost hiker. The duo trudged back down the mountain to report their unfortunate findings. Once the remains were recovered, it was clear that the body was not recent at all. Scientists determined that the Iceman was more than 5,000 years old and named him Otzi. The discovery was unlike anything scientists had ever before seen because the body was so well preserved. For years, Otzi was studied by scientists who discovered that our ancestors have a lot more in common with us than we ever knew before. Otzi was covered in ink body art. Research done on the contents of his stomach revealed that his last meal was dry cured meat, similar to the bacon we eat today. Otzi has at least 19 relatives living today, somewhere in Central Europe. Scientists were researching ancient squirrel burrows in Siberia when they came across something interesting. One of the squirrels had hidden away precious seeds deep beneath the ground. The seeds had been encased in ice for 32,000 years. The seeds were for the flower Silene stenophilia, which had long since gone extinct. Amazingly, scientists were able to recover plant tissue from inside the seeds and grow an entire crop of flowers. They've since reintroduced the previously extinct flower to natural habitats all across the world. In 1930, a team of Norwegian scientists sailed around the Arctic Ocean, conducting research on the seas and glaciers. They reached White Island, a dangerous and icy land no human had set foot on before, or so they thought. The scientists were shocked to discover the tip of a small boat sticking out of the snow. Frozen inside the boat, they found scientific equipment and various personal items, including a jacket monogrammed S.A. Andre. They had discovered the wreck of the famous Andre Arctic balloon expedition. In 1897, Swedish explorers, led by Andre, attempted to travel to the North Pole by hydrogen balloon. No one had ever heard from them ever again. People only found out what happened to them when the wreck was discovered 33 years later. It turns out that the balloon had crashed on White Island only 2 days after departing from Sweden. The explorers traveled along the island on a small makeshift boat, but were unable to make it any further. The best preserved woolly mammoth ever found was discovered in an area of permafrost in Siberia in 2010. Scientists named the frozen mammoth Yucca, after the small village near where it was found. Yucca had been frozen for 39,000 years and is thought to have been around 6 to 8 years old. Because Yucca is so well preserved, it has been studied for years and provided new information about mammoths. In 2019, scientists reported that they were able to activate cells taken from Yucca's tissue. Maybe one day we'll have woolly mammoths roaming the land. From looking at pictures and videos of Antarctica, the continent appears to be freezing cold, covered in snow, and flat, except for a few small hills. Scientists believe that too. When studying the Gomburtsev Mountains in the early 2000s, they were shocked to discover that the small rocky hills were actually the peak of a gigantic mountain formation under a mile of snow. Using radar technology, researchers worked out that the mountains are really around 10,000 feet tall and sprawl across 750 miles. This is around the same size as the European Alps, except hidden under tons of ice and snow. At a gold mine in Siberia, a businessman was examining a nearby river when he noticed something interesting in the frost. It was a small woolly rhino calf that was later named Sasha. The woolly rhino has been extinct for 15,000 years. It's thought that Sasha could have been frozen in the ice for up to 39,000 years. Sasha is unique because it's the only full-body woolly rhino to have ever been discovered. Glaciers around the northern Italian town of Pelo have begun to melt. Artifacts from decades and even centuries ago have been discovered pouring out of the ice. Personal belongings from soldiers have been found, things like diaries, photographs, and even love letters. Historians have even uncovered an entire cabin preserved beneath the ice. The cabin was filled with hard metal helmets and clothes. In 1845, Sir John Franklin embarked on an ill-fated expedition to the North Pole. The crew traveled on 2 ships, HMS Erebus and the ironically named HMS Terror. The expedition met with disaster, and both ships were lost to the icy waters. In 2016, the HMS Terror was discovered by a team of researchers. Despite being lost for 170 years, the freezing cold waters had maintained the ship in pristine condition. Scientists described the ship as frozen in time. Dinner plates and glasses were still on shelves, beds and desks were still in order, and even the passengers' luggage appeared to be in good condition. The HMS Erebus was also discovered nearby, but due to changing water conditions, the ship wasn't in great shape. The glacial ice surrounding a mountain passageway in Norway that was notoriously used by the Vikings has revealed hundreds of ancient artifacts. One of these artifacts was a giant unopened wooden box that was welded together. Researchers were beside themselves with anticipation, waiting to open this box. They believed it would be filled with Viking treasures or artifacts that would give us an insight into ancient society. When they opened the box, all that was inside was a plain old beeswax candle. It turns out that this box wasn't actually as old as they thought it was. By analyzing the candle, they discovered that the box dates back to the 17th century. The age of the Vikings had ended by the 11th century. It's likely that the candle box belonged to a farmer who was shipping it from his summer farm to his winter farm to light up the long nights.
There are a lot of unanswered questions in physics. How did universal energy and matter appear? Where did gravity come from? And much more. We've been trying for years to get answers to these questions, and one of the people who tried to do this was Paramahamsa Tiwari, the author of the so-called space vortex theory. What is this theory, and what does it say about the hidden laws of our universe? Let's figure it out. Paramahamsa Tiwari was the former executive director of the Nuclear Power Corporation, India. He took the space vortex theory, or SVT for short, first proposed by René Descartes and finalized it. He was always inspired by physics and its greats, even since his days as an electrical engineering student. After rigorous studies of the laws of physics, he discovered new equations defining matter and the mass and charge of the electron. After that, he came up with the SVT. This theory tried to explain the unexplained phenomena in physics, including the creation of the electron and gravitational, electrostatic, and electromagnetic energy fields, as well as other things. It also described the 6 hidden laws of the universe that underlie our entire world. But first of all, let's talk about the theory itself. Space vortex theory suggests that the universe is made up of vortices, or swirling patterns of energy. And according to SVT, these vortices are the fundamental building blocks of the universe. They're the driving force behind the laws of physics and the fundamental principles of our world. Basically, everything in the universe is connected and interconnected through these vortices. This theory isn't very based on any real observations, but rather on mathematical models and computational modeling. For example, some computational models showed how these vortices work in hydrodynamics and plasma physics. They showed that vortices in such systems can have a central point of attraction and can be interconnected. Other models were used to study how the energies inside the vortices move and how they can create different frequencies and vibrations. But some experts have criticized SVT for using only models and simulations. The biggest criticism is that this theory can't actually be tested. It relies on mathematics and not on some experimental data. That's why it's not accepted as a mainstream scientific theory. But it's still quite interesting and provides a unique perspective on the universe and our understanding of the laws of physics. For example, according to SVT, the universe has some underlying hidden rules that cause the creation of fundamental matter, their assembly, and movement. What are these laws and what do they say? Well, let's take a look at them. Law 1. The universe has only one primordial entity, space, i.e. absolute vacuum, that structures matter. This law states that space is the fundamental building block of the universe and that it's responsible for structuring matter. It suggests that space is the fundamental entity that creates and maintains the structure of matter, and that all matter in the universe is made up of the same fundamental particles, like electrons and positrons. Let's try to put it in simple words. Imagine that the universe is like a big Lego set. Just like how all the Lego bricks are made up of the same basic building blocks, the universe is made up of the same fundamental building blocks too. And these blocks are called electrons and positrons. But what holds these blocks together? Space, of course. Space gives it shape and structure, just like how the plastic container holds all the Lego bricks together in a set. So, the first law states that space is the fundamental building block that structures matter and holds everything together in the universe. Law 2. Matter is constituted with multiples of only one kind of fundamental particles, electrons and positrons. This law states that all matter in the universe is made up of the same fundamental particles, the electron and positron. These two are the Lego blocks we've talked about before. And according to the second law, these tiny invisible particles make up everything from a tiny atom to a giant galaxy. Just like no matter what the shape or size our Lego build is, it's still made up of the same building blocks. Law 3. the field distribution in space as recognized by contemporary physics, linked with and emanating from matter, are effects arising from only one fundamental field in space. This law states that the fields recognized by contemporary physics, such as the electromagnetic and gravitational fields, are effects arising from a single fundamental field in space. It suggests that this fundamental field is responsible for creating everything that we observe in the universe. So let's try to put it simply. This time, imagine that the universe is like a big playground. All the different fields we observe, such as the gravitational and electromagnetic fields, are like different games we play in there. But no matter what we play, we're still in one fundamental space. This is the playground itself. It's the base that holds everything together. According to the third law, without the playground, we wouldn't be able to play any games. And without this fundamental field in space, we wouldn't be able to observe any fields in the universe. Law 4. There is no void in space anywhere in the whole universe except at the centers of the fundamental particles of matter, electrons and positrons. This law states that there's no truly empty space in the universe and that all space is filled with the fundamental field, the one we talked about before. It says that electrons and positrons can be found everywhere, and even the things we consider to be empty, like vacuum, are actually full of tiny particles. And according to this law, the only truly empty spaces we can find in the universe are at the centers of the fundamental particles, electrons and positrons. Law 5. From only one fundamental universal constant, all the constants considered universal in contemporary physics are derivable. This law states that all the constants considered universal in contemporary physics can be derived from a single fundamental universal constant. It suggests that all the constants in physics are interconnected and can be explained by a single fundamental principle. I know you've been doing a lot of imagining lately, but bear with me. This time, please imagine the universe as a big recipe. All the constants in physics, such as the speed of light, the gravitational constant, and the Planck constant, are like the ingredients. They're very different and there are tons of them. But just like how all the ingredients in a recipe are interconnected and come together to make one dish, all the constants in physics come together to make the universe. And just like how a recipe has a main ingredient that holds everything together, physics also has a single fundamental constant that holds everything together. Law 6. The spatial structure of submicrocosmic fundamental matter is repetitive uniformly in the spatial structures of macrocosmic bodies like planets, stars, and galaxies. This law states that the structure of the fundamental particles that make up matter is repetitive and uniform across all scales, from subatomic particles to macrocosmic bodies like planets, stars, and galaxies. It suggests that the same fundamental principles govern the structure of matter at all scales. Let's go back to the analogy with the recipes and cooking. Using different ingredients and combining them in different ways, the chef can create new dishes. These will all be different dishes and they can be very simple or very complex. But when creating them, the chef still applies the same basic rules and knowledge they have, right? And just like that, the universe also creates different structures, from atoms to planets, stars, and galaxies. But it still uses the same fundamental principles to create all these things. So, this law suggests that the structure of the fundamental particles that make up matter is repetitive and uniform across all scales. These are the 6 fundamental laws of the universe according to the SVT, and even though it's not accepted by mainstream science, it's still a pretty interesting concept.
You're traveling through deep space, circling stars and entire galaxies. Whoa, looks like this multicolored nebula will soon collapse under its own weight and explode like a supernova. Now let's carefully circle this black hole. Try not to get caught in its gravitational field, or it'll swallow you like a space monster. Wait, what's that strange structure right there? It's a glowing wall. And if you look closely, each glowing dot is an entire galaxy. That wall has about 100,000 of these galaxies. The Milky Way has 100 billion stars, so this wall holds a quadrillion, that's 10 followed by 15 zeros, of stars like our sun. This giant structure is called the South Pole Wall. It's located about 500 million light-years from Earth. By comparison, the closest star to our home is Proxima Centauri, and it's about 4.2 light-years away. Rockets can cover that distance in about 73,000 years. So the journey to the South Pole Wall may take longer than our solar system exists. And this wall is simply gigantic, even on a cosmic scale. It's about 1.37 billion light-years long. To give you an idea of how large that is, the Milky Way is only 100,000 light-years wide. But you can't see this wall even with the most powerful telescope. The problem is that the Milky Way itself obstructs your view. It's so bright that it's hiding this wall. It's like trying to look at the starry sky in a metropolis. The light pollution won't let you do that. Scientists have been able to detect this galactic wall by measuring redshift. We know that all objects in the universe are moving. They spread out from each other as a result of the Big Bang, which happened billions of years ago. And when galaxies move, their light waves change slightly. By measuring this change, we can understand what the object is and how it moves. And this wall isn't even the largest in our universe. This is the Hercules Corona Borealis Great Wall. It's a giant flat superstructure about 10 billion light-years wide. That's around 10% of the entire observable universe. And it's also a wall. That is, a cluster of galaxies. We were able to detect this giant structure by gamma-ray bursts. It's the brightest electromagnetic event in the universe. You could even see it in the far reaches of our universe. Such bursts are a very rare event. In the Milky Way, for example, it happens once every few million years. If we notice many such bursts in a short time from the same place, it means that there are many objects like the Milky Way in that place. So, there are a lot of galaxies out there. Another unusual giant structure in the universe is the huge, large quasar group. It's about 4 billion light-years across. So it takes a photon of light almost as long as our planet has existed just to get from one side of the structure to the other. And if you put the huge, large quasar group on the scale, it would be 6.1 billion times heavier than our sun. Scientists have found that there are at least 73 quasars in that structure. These are some of the most unusual objects in the universe. They are the active cores of galaxies. At the center of a quasar is a supermassive black hole. This giant eats up the matter around it. A wild force of gravity twists the matter around the black hole, forming a disk. And this disk is the source of the strongest radiation out there. By comparison, the radiation from a single quasar is tens or hundreds of times stronger than that of all the stars in our galaxy put together. Because of such strong radiation, we can detect quasars, even at very long distances. That's why they're also called beacons of the universe. Scientists use quasars to study the universe and the movement within it. One of the most distant quasars from us is about 13.1 billion light-years away. This makes it one of the oldest objects in the universe. It appeared about 690 million years after the Big Bang, and it's almost 3 times older than our solar system. It's still glowing with extreme brightness, about 4 and 14 zeros times brighter than the sun. Scientists explain that at the center of the giant is a supermassive black hole, 800 million times heavier than the sun. All these giant structures are just building blocks of our universe. Look, this is our solar system. Now, zoom out a little, and this is where our home star is in the Milky Way galaxy. Zoom out again. Here's a local group of galaxies. All the bright spots here are galaxies. Here's Andromeda, and here's the Triangulum galaxy, plus a few dozen other slightly smaller galaxies. They're all gravitationally connected. The size of this structure is about 10 million light-years. That's 100 times the width of our galaxy. Zoom out, please. This one is the Virgo supercluster. It's 20 times larger than the local group. There are about 30,000 different galaxies, and the mass of the whole thing is about 1 in 15 zeros solar masses. Zoom out again. Laniakea. This structure is almost 3 times larger. It includes the Virgo supercluster and other smaller clusters. And there are about 100,000 galaxies here. It's not over yet. Zoom out one more time. Here's the Pisces-Cetus supercluster complex. This giant galactic structure contains about 60 clusters of galaxies. So there are more galaxies in it than grains of sand in the desert. You know what to do. Zoom out! Phew, this is the observable universe. There are over 500 billion galaxies. And the stars? Well, there are about 1 billion trillion stars. The observable universe has its own structure. Clusters of galaxies form chains and walls, as you've seen before. But these strands are separated by huge regions of absolute emptiness. These areas are called voids. In these places, there is no matter at all. There are fewer molecules in the voids than in an empty room. One of these voids has a very mystical reputation. It's the Eridanus supervoid, or the cold spot. It appeared here only 380,000 years after the Big Bang. It's almost 1 billion light-years wide and could hold hundreds or thousands of galaxies with trillions of stars. Some scientists believe that this cold spot may have been the result of the largest collision ever, a collision of universes. There's a theory that our universe is some kind of bubble, a huge sphere that contains all these walls and chains of galaxies. Now imagine that there's an infinite number of these bubbles. They could be parallel worlds or different universes. Many years ago, one bubble came close to the bubble of our universe. Their walls touched, and the two universes connected for a while. It's like two drops of water coming together. But that universe kept moving. The area where the bubbles joined became thinner and thinner until that connection broke, and the two bubbles detached from each other. At this point, the second universe ripped some of the material out of our bubble. All those galaxies that used to fill the Eridanus supervoid ended up in a parallel universe. Scientists supposed we might travel through other bubbles. Flying to the supposed wall of our universe would take forever, and then it would take even longer to fly through interuniversal space. So we have to use portals, or wormholes. Here's how it works. Imagine a piece of paper with point A on one side and point B on the other. Instead of moving all the way across the sheet of paper, we just fold the sheet so that point A is right above point B. All that's left to do is make a small hole, and the journey takes only moments. Some scientists believe that such shortcuts through universes lie inside black holes. But how do you survive falling into a black hole? You just have to pick one that's big enough. It's all about gravity. Imagine you're falling into a black hole right now. The closer you get to it, the stronger effect it has on you. It intensifies with every inch. At one point, the gravitational force that affects your head is much stronger than the one that affects your feet. Then you turn into spaghetti. Yum. But if you choose a supermassive black hole, like the ones at the centers of galaxies, the gravitational force in them increases gradually. They can be millions of times heavier than the sun and much bigger, but the gravitational force on your head and your feet will be almost equal, and you will still feel comfortable. Who knows? Maybe if you managed to survive a fall into such a massive black hole, you'd find yourself in a completely different universe where different laws of physics apply. But so far, this is just a theory. Look up when the sky is clear at night. You'll see thousands of tiny bright dots there. It may seem like they're fixed in one spot, but in reality, they're constantly moving. In 100,000 years, there won't be a constellation with the same shape or pattern we know today. And think about all those red dwarfs, small stars, planets, space bodies we can't see with the unaided eye. Red dwarf stars are especially cool. They're usually about half the size of our sun, and mostly 1/10 as bright. They may not be the brightest things in the sky, but they live for a very, very long time. Nuclear fusion reactions happen deep in star cores. That's what makes them shine. Large stars release huge amounts of energy, burning their stellar fuel. But such stars tend to burn all their fuel in only a couple of million years. Stars like our sun usually live for about 10 billion years, but red dwarfs don't use that much of their fuel. Their light is not so powerful, and they don't require much energy to support their existence. They're like energy-efficient cars. That's why they can last hundreds of billions of years. Some of the smallest ones may live for up to 10 trillion years. most hydrogen in sun-like stars remains unspent. There's more of this gas in the atmosphere rather than in the core of such stars. This means most hydrogen doesn't take part in the fusion reactions, but it's different with red dwarfs. They circulate plasma throughout their entire bodies. These stars pull fresh hydrogen reserves from their outer layers into their core. That's what keeps fusion reactions running. One day, in the distant future, stars like our sun will run out of fuel and shut down. The universe will be full of small red dwarfs. They won't have enough energy to shine and brighten the space around them. Our descendants, if there are any, will inherit a dim, dark cosmos. As it gets older, the sun will balloon to a size where it will destroy nearby planets. First Mercury, then Venus, and then us. On the other hand, Earth will probably survive, but barely and not for long. The sun will burn it to a crisp when it gets closer. The outer planets of our solar system will also survive, but they'll move even farther away into space. The sun will lose some of its mass while increasing in size. Its gravitational pull establishes the orbits of the planets. When our star becomes less massive, the pull of its gravity will become weaker, and the outer planets won't have such a strong connection with the sun. Our solar system is not isolated. There are many other stars in our galaxy. Within 30 billion years, stars that travel nearby will mess with our outer planets, enough to rapidly launch some of the biggest ones out of the solar system altogether. The last planet to stay will stick around for a while longer, maybe even 100 billion years. But even that one will eventually end up kicked out of the solar system. There's a theory claiming that we got most of the water on our planet from ice-laden meteorites and comets, frozen balls of ice and dust. As they crashed into the early Earth, they probably brought water, which was necessary to develop life. But those very same objects that might have created life on our planet could also be its end. This is not a matter of if, more a matter of when. And scientists think it's very likely that an asteroid or comet big enough to wipe out life on Earth will smash into our planet. But it'll happen in the distant future. And fortunately, we have the technology to predict such things and react on time. But there are other cosmic collisions we can't avoid, no matter what we do. Andromeda, our neighboring galaxy, is moving toward the solar system at a speed of 68 miles per second. There are 2.5 million light-years between the Milky Way and Andromeda, so luckily our neighbor won't cover that distance anytime soon. It'll only happen in around 4 billion years. Such a collision of two galaxies might lead to real chaos for our descendants, if any of them are still living on Earth, that is. The two galaxies will slide past each other. Then they'll draw apart until the gravitational force starts pulling them back together. As they merge, they'll both lose their disk-like structure and form one big elliptical galaxy. It's already got the nickname Milkomeda. The Milky Way as we know it today won't exist anymore. Space is in constant motion, changing all the time. Scientists have a couple of possible scenarios of what might happen with the universe in the future. Number 1, the Big Rip. This theory claims that the universe will expand infinitely. At one point, the pull of the expansion will get stronger than the gravitational force keeping it all together. If this happens, it will tear apart galaxies, stars, black holes, and all other space bodies, including Earth. The universe will turn into a bunch of disconnected particles. Until about 5 billion years ago, the universe was expanding slowly because of its powerful gravitational pull. Then its growth sped up. Some experts say it happened because of the effects of dark energy. Dark energy is a mysterious force that makes up almost 70% of our universe. This force pushes it to expand faster rather than slowing it down. So, in the case of the Big Rip scenario, dark energy will win over gravity to the point where it will be able to rip apart individual atoms. Scenario number 2, the Big Crunch. There's a possibility the universe will get to the point where it'll stop expanding. Gravity will become a dominant force. It might even reverse the expansion of the universe. Then, the cosmos will start shrinking, making planets, stars, and even entire galaxies collide. In the end, the whole universe will collapse in on itself. Once everything compresses into one infinitely small point, which is something called the Big Crunch, the universe may start expanding once again. Theory number 3, the Big Freeze. Brrr. In this scenario, entropy will grow until it reaches its maximum value. Entropy is basically the idea that everything in the universe declines into disorder at some point. Once entropy gets to its maximum, the heat in the system will be spread evenly. The universe will then disappear because there won't be any room for heat to exist. Any mechanical motion inside the universe will stop. The cosmos will be so empty and gas will be so thin that no new stars will be able to form or shine again. In such a cosmos, time is just an endless void. Nothing ever happens with planets, stars, or living beings. The entire universe is frozen, dark, and motionless because there's no energy that can make things start working again. Many, many billions of years after the last stars burn out and fade, black holes will send a message that the universe has come to an end. Black holes are areas with extremely strong gravitational pull, so powerful that nothing can escape it. They can be as massive as 100 suns. As for supermassive black holes, their mass can be greater than that of 1 billion suns. You can find such giant black holes at the center of most galaxies. Like everything else, black holes will experience the same end. But when their moment comes, they won't gently disappear into the night. Black holes will go away in enormous bursts of fireworks, lighting up the universe in the last moments of their existence. It will be the end of the entire era. Black holes usually survive by gobbling down the stars and gas that come close enough. Their gluttony is the main feature that gives them away. In most cases, there's an accretion disk around a black hole. That disk is made of all those materials and particles it's torn apart and is pulling inside, similar to when water swirls down a drain. As the materials and particles draw closer, they start to move faster and faster. This generates heat, which makes the accretion disk glow, which again gives away the black hole. Yep, black holes aren't that great at hide and seek. Things that cross a black hole's event horizon, which is also called the point of no return, are lost forever. But Stephen Hawking had a theory that you might be able to escape from a black hole. There are particles moving even in a vacuum. Let's say one particle has positive and one has negative energy. If they both come close to a black hole, there's a chance that one will fall into it while the other will escape. That means the black hole has radiated the particle away. And this particle has taken some of the black hole's mass with it, which is why the black hole may start shrinking. As it begins to evaporate, it loses its mass and slowly becomes smaller. More and more particles start leaving until all the energy that's left behind escapes all at once. In the final tenth of a second, there will be a giant flash of energy and light in a very, very small region of space. And then, it's all gone.
Imagine a being so powerful it can suck in entire galaxies, so mysterious it's invisible to the naked eye, and so impressive it bends the very fabric of space and time to its will. Yes, meet my mother. Just kidding. Actually, meet the ultimate superhero of the universe, the black hole star. What is it and how does it work? Well, let's find out. The universe is full of marvels, and the black hole star is one of the most impressive ones. It's a supermassive force that can bend the laws of physics and a true enigma for scientists to unravel. No wonder science fiction writers find them so captivating. A black hole star, also known as a quasi-star, is a hypothetical type of extremely massive and luminous star that may have existed early in the history of the galaxy. They're predicted to be as luminous as a small galaxy, but unlike modern stars, they weren't powered by nuclear fusion in their cores. A quasi-star's energy would come from material falling into a black hole at its core. And yes, just like a normal black hole, these stars have the power to suck in anything and everything that gets too close, including stars, dust, and even entire galaxies. But how is it possible that the star is born from a black hole? And what's more, how do they continue to coexist together? Well, first let's discuss how black holes are born in general. It all starts with a supermassive star, one that is at least a few times more massive than our own sun. This giant of a star burns bright and hot, shining with the light of 1 million suns. But eventually, it runs out of fuel and its fate is sealed. As its lifespan comes to an end, it makes one final massive boom, a blast so powerful it can outshine an entire galaxy. This blast is called supernova. During this boom, the outer layers of the star fly away, while the core gets squished together by its own gravity. If the squished core is heavy enough, it can keep squishing until it becomes a black hole. And just like that, a black hole is born. Don't even try to put diapers on this thing. Now, this cosmic monster baby can continue to grow by swallowing up anything that comes too close, including stars, dust, and even entire galaxies. This is basically what's happening now in our universe with supermassive stars. But what about quasi-stars? The formation of a quasi-star could only happen early in the development of the universe, before hydrogen and helium were contaminated by heavier elements. And because of that, quasi-stars have one important feature. They are gigantic, so enormous that it's literally impossible to imagine. They may have been dwarfing even the largest known modern stars, like VY Canis Majoris and Stephenson 218. No wonder they're so scary. They were born from protostars, one of the first stars in the universe, the great-great-grandfathers of, everything. So now, imagine a protostar so massive that its core collapses into a black hole, just like we described before. But the key difference is that in a regular supernova, the outer layers of the star are blown away by the energy released during the boom. Meanwhile, in a quasi-star, these outer layers are massive enough to absorb the energy without being blown away. What do we get in the end? A star with a black hole in its core that weighs from 1,000 to 10,000 solar masses. This quasi-star is about 14,000 times bigger than our Sun, which makes them bigger than any star we know today. These celestial titans have some pretty crazy properties. Once a black hole is formed at the center of a giant protostar, it starts to give off a ton of energy. This energy helps to balance out the force of gravity, making it kind of a giant fusion-based star. They would be so bright that each one would look like a small galaxy. Quasi-stars would have a pretty short lifespan, around 7 million years. Just for comparison, our Sun is about 4.5 billion years old, and it's only halfway through its lifetime. But either way, during this short period, the black hole at the center would grow to be about 1,000 to 10,000 times the size of our Sun. Quasi-stars are also thought to be super hot, with temperatures reaching over 17,500 degrees. But as a quasi-star gets older, it starts to cool down, and its outer layers become see-through. Eventually, it cools down to a temperature of 6,740 degrees, and at that point, it's curtains for the quasi-star. It can't survive at that temperature, so it just dissipates, leaving behind an intermediate mass black hole. Unfortunately, right now, there's no observational evidence for the existence of quasi-stars. This is because they're thought to have only existed a very, very long time ago. They may have been very massive population 3 stars, which are extremely rare and difficult to detect. It's also very unlikely that any of them would still exist today because of their super short lifespan, only 7 million years. So why do scientists believe that quasi-stars could have existed? Because they're looking for ways to explain how supermassive black holes formed so early in the history of the universe. They're found at the center of most galaxies. But how could these monsters have formed so quickly? After all, it takes a really long time for small black holes to grow into supermassive ones. This is where the idea of quasi-stars come in. These stars aren't just destructive forces of nature. They're like the black belts in the martial art of gravity. They can bend and twist anything to its will. That's why these stars, if they really existed, had to play a crucial role in the evolution of galaxies. They must have been instrumental in shaping the universe as we know it. So, those intermediate-sized black holes that they left behind could eventually turn into supermassive black holes in the center of galaxies. But we're still yet to solve this cosmic mystery. Detection and study of black hole stars is like trying to find a needle in a haystack. Only instead of a needle, it's an invisible and mysterious object. And instead of a haystack, it's the vast expanse of space. But with the help of some pretty cool technology and a lot of brain power, scientists are getting closer to uncovering the secrets of these celestial giants. Here are some things that can help us in this research. First of all, gravitational waves. They're like ripples in the fabric of space-time, caused by the movement of massive objects. Albert Einstein predicted them way back in the 20th century, but they were finally detected only in 2015. We caught them by observing the collision of two black holes. This discovery confirmed that black holes can merge and that they're a powerful source of gravitational waves. Scientists think that by studying these waves, they can learn more about how black holes form and grow. We can also try to detect quasi-stars by observing the effects of their gravity on nearby objects. It's like trying to spot a criminal by their fingerprints. For example, if a black hole is located near a star, scientists can observe the star's light being distorted as it's pulled toward the black hole. And of course, we can use our technologies, such as X-ray, infrared, and radio telescopes. This allows us to study black holes in various ways and at different stages of their lives. In other words, scientists are working hard to uncover the secrets of these celestial giants. We develop new telescopes, search for primordial black holes, and try to understand the connection between black hole stars and dark matter. And we're making some pretty incredible discoveries, just like with gravitational waves. All these things will bring us closer to uncovering the secrets of quasi-stars. And when we find out the truth about them, it will become a new page in our scientific history.